Okay, everyone, welcome back. We'll do the last two examples on this in this lesson about using logs to make predictions. So this is for you poker players out there. This is for you. Um, the prize for an annual poker tournament was 0.33 million in 1974, and was 6.79 million dollars in 2012. Assuming exponential growth, when will the prize be over 20 million? Okay, so keyword there is exponential growth. So first we have to come up with a formula for the value of the prize in terms of t. So if we let f of t be the value of prize in millions of dollars, t years after 1974, then we're going to have in this situation. The exponential growth says that f of t is going to be some constant a times another constant raised to the tth power. And we know when t equals 0, that corresponds to 1974. So the value, so f of 0 is 0.33, and 2012 is exactly 38 years from 1974. So that is uh, 38. So f of 38 is 6.74. And then we go about solving for a and b like we did last time in the last lesson. We can say that we get these two equations, substitute this in, so 0.33 equals a times p to the 0. P to the 0 is 1, so we get a is 0.33. And then we can substitute that into the second equation, and we get 6.79 equals 0.33 times p to the 38. And we can go ahead and divide both sides by 0.33 and raise both sides to the 1 over 38th power, and that's b. And b is approximately 1.082834. In these prime problems, you really want to take as many decimal approximations as you can, or decimal places you can, okay, to prevent any round-off error. Okay, so now we know what a and b are, and f of t is this. And now we want to find when is f of t equal 20. So now we get to the solving the exponent part of this example. We want to isolate this 0.33. So we'll divide by 0.33. And then we can go ahead and take the logs. Okay, we could write the log, but it would be kind of weird to write log base 1.02828834. So we're just going to take the common log of, we'll simplify this to 60.606006. And now we can take the common log of both sides, divide by one of the common logs, and we get this. We get that so what happens is, I omitted this step, but we take the log of this number equals t times the log of this number, and then we divide by the log of this number, the second number. That's how we get this. How we get 51.57. So we want to round up, because that says we'll have to go at least 52 years before the prize is 20,000. So it should really be 1974 plus 52, which is 2026. Okay, so that's when we can expect the poker prize to be that have that value. All right. For the last example, this involves half-life again. We're back to talking about this mysterious radioactive element X. And in this example, it has a half-life of 5,214 years. Again, what that means is that it takes that long for it to decay to half its value, or 50% of its value. So a piece of wood is found by an archaeologist and has 12% of its original content of element X remaining. And we want to know how old is this wood. All right. So the way we do that, once again, we can come up with a function to let f of t be the percentage of element X after t years. And we know it has exponential growth, or in this case exponential decay, so it's in this form. And we know that its original amount is 100%. Original amount of element x is 100%, so f of 0 is 100, and f of 5214 is 50, because that's its half-life. Once again, from the first equation, we get that a has to be 100 because b to the 0 is 1, and we can substitute that in here. So we get, so replace a with 100, then divide both sides by 100. Okay, 50 over 100 is 1/2. So we have 1/2 equals b to the 5214. Now we raise both sides to the 1 over 5214 power. Now I'm not going to do this, enter this into my calculator just yet, because it might be a little too small for the digits to be significant. But I'm just going to leave it right there, and I'm just going to substitute that and write it in this way. So f of t can be written as 100 times 1/2 raised to the t divided by 5214. And this whole thing is the exponent here. So we want to find when is the t such that f of t is equal to 12. Okay, so we want to solve that. Now, what we're going to do is we're just going to solve for this fraction. If we know what t divided by 5214 is, we can just multiply by 5214 and get t. So I'm going to focus on isolating this exponent. First, before we do that, we want to get rid of this 100. So we divide 100 by both sides. And of course, 12 divided by 100 is 0.12. And now we can go ahead and take the log of both sides. And what we did here is we took the log of this side and then brought this exponent out in front. Now we're going to divide both sides, but we're going to isolate this part. So we're going to isolate this, and we're going to get rid of this log of 1/2. So we're going to do that by dividing by log of 1/2 by each side. And now we can see we're almost done. We just have to multiply by 5214, so we will do that. And now we can plug everything into our calculator. And we get that the piece of wood is 15,949 years old, approximately. All right. Study these examples. Watch this video as many times as you want and get some practice on the homework. Good luck, and we'll see you next time.